This video is going to discuss finding limits using tables. If you haven't watched the video about using graphs to find limits, that video includes a quick introduction to limits. I would suggest watching that first. So let's just start by doing an example. Find each limit using a table of values. I want to find the limit as x approaches 1 of ln x divided by x minus 1. When we are finding limits, we don't actually care what happens when x equals 1. And so if I want to use a table to find a limit, I actually care about what happens when x is close to 1. So I want to pick numbers that are a little bit smaller than 1 and are approaching 1 from the left. So I might pick something like x equal 0.9, x equal 0.99, x equal 0.999. These are x values that are approaching x equal 1, coming in from the left. And then I want to pick some x values that are a little bit bigger than 1, coming in from the right side. So I might pick 1.1, 1.01, 1.001. That would be my approaching 1 from the right. To complete this table of values, I'm going to plug each of these numbers into my function using a calculator. I like using Desmos as an online calculator because when I use Desmos, I can just type in the function. So I just typed in ln x divided by x minus 1. I hit enter, and then I typed in my x value. So when I typed in x equal 0.9, I can see that the function is equal to 1.0536, etc. And the nice thing about using this type of calculator is then I can delete this x value and type in my next x value, and the number on the top line will change as I type in new x values. So I went ahead and put all of these x values into a calculator and completed my table of values. So I can see that as x approaches 1 from the left, as the x values are getting closer to 1, these y values appear to be getting closer and closer to 1. And if it wasn't obvious that they were approaching 1, I could put more x values into my table. I could try 0.99999, etc. And these x values are getting closer and closer to 1. So that means my left-hand limit is 1. And then if I look at what happens on the right side, my y values are also approaching 1 on the right side. 0.999 is pretty close to 1. So this means my right-hand limit is also 1. Because we're approaching 1 from both the left and the right, that means this limit, this two-sided limit, is equal to 1. All right, let's take a look at another example. I've got the function f of x is x plus 2 if x does not equal 4, and f of x is 5 if x equals 4. So this is a piecewise defined function. This means we use the top definition anytime I have an x value that is not 4, and I use the bottom definition 5 only when x equals 4. I want to find the limit as x approaches 4. So once again, it doesn't matter what happens at 4. I don't actually want to plug 4 into my table. Instead, I want to approach from the left, so I want to pick x values that are smaller than 4. I chose 3.7, 3.9, 3.99. I'm approaching from the left. And then I want to approach from the right. So I want to pick values that are larger than 4 and get closer and closer to 4. So I did 4.3, 4.1, 4.01. Now, when I complete this table of values, because all of the numbers in my table are not equal to 4, I'm going to use this top definition, x plus 2. So for the first one, 3.7, I plugged that into x plus 2, and I ended up getting 5.7. This one I didn't have to use a calculator because you just added 2. So I can see that on the left side, my y values are 5.7, 5.9, 5.99. And on the right side, I've got values that are 6.3, 6.10, 6.01. So that means my y values are approaching 6 on the left, and they're also approaching 6 on the right. So this limit is equal to 6. Again, it's really important to notice that it doesn't matter what happens at x equal 4. We just care about what happens when we're close to 4, which means we're not actually at x equal 4. All right, here's another one. I'm going to find the limit as x goes to 0 of 1 over x squared. So if I approach 0 from the left, I'm going to choose x values that are smaller than 0. So I did negative 0.1, negative 0.01, negative 0.001. And then I approach 0 from the right, so I picked values that are bigger than 0, 0.1, 0.01, 0.001. And I plugged these numbers into my function and created my table of values. In this table, I can see that on the left side, my y values are getting larger and larger and larger, and they appear to just be growing without bound. And the exact same thing is happening on the right side. 100, 10,000, 1,000,000, the y values are just getting bigger and bigger. When this happens, this actually means we have a vertical asymptote. We saw an example of that in the previous video when we were looking at graphs. But what this is saying is when I come in from the left side of my graph, my y values are getting huge. My y values are going up towards infinity. And the same thing is happening when I come in from the right. The y values are approaching positive infinity. The y values are growing without bound. And so when this happens, we say our limit equals infinity. All right, here's another one. Limit as x goes to 2 of 1 over x minus 2. So I chose x values that were smaller than 2 to come in from the left, 1.9, 1.99, 1.99. I took these values, I plugged them into my function, and I got negative 10, negative 100, negative 1,000. So these values are also growing in magnitude, but they're negative. And then on the right side, I chose values that are a little bit bigger than 2, 2.1, 2.01, 2.001. And I got 10, 100, 1,000 values that are growing. So what's happening in this case is as I approach 2, I think I have these labeled wrong. Let me fix that real quick. Just my text. So as I approach 2 from the left side, my y values are approaching negative infinity. I can write this as a one-sided limit. As I approach 2 from the left, I get negative infinity. There's a vertical asymptote here. If I look at the second half of the table, as I approach 2 from the right, values that are bigger than 2, my y values are going to positive infinity. So I can write that as a right-hand limit. As I approach 2 from the right, I get positive infinity. Because my left and right limits aren't the same, that means my two-sided limit actually doesn't exist. All right, that was my last example in this video. Please let me know if anything's unclear. Thanks for watching.